Carlos?
Yes.
Did you see the request from San Francisco about resending them the link?
No. I can check it really quick.
I just got an email from Julie Ortiz saying that she had accidentally deleted your email, so she just emailed you to resend her and Amanda Doherty with SUC the link.
Okay.
I was wondering if you could do that, and then we'll go ahead and get started, I guess.
Sure. Remind me again who needs to enter.
If I forward them my link, it's not a problem, right? Or do they need their own links?
I can do it here, actually, from this. I believe from
Julie
this.
Ortiz.
Julie Ortiz. You know what? Just so it's faster, go ahead and send them your link. It should work just fine.
Okay. Okay. I went ahead and sent it to Julie. So why don't we go ahead and get started? She'll probably get on pretty soon. So good morning, everyone. Welcome to the webinar. This is the project update, or our kind of showcase to show what we've actually accomplished on this project since 2008. And I'm Fiona Sanchez with Irvine Ranch Water District, and I'm going to be co-presenting with Carlos Ortega. And for those of you who don't know Carlos, he is with Enterprise Information Systems. He has been the consultant that has been working with us on this project to implement the data protocol, and he has also been a consultant to DWR on their CIMIS work. So he has a lot of knowledge of those systems and has worked collaboratively with DWR. What I want to do right now is maybe have everybody that's on the call, if we could try and do introductions. I realize it's kind of hard when there's quite a few of us on, but if folks just want to let us know if you're on the call and which agency you're with. So go ahead.
Dave Langridge, East Bay Mud.
Ashley Carter, Santa Clara Valley Water District.
Kamiko Higashiyama, LADWP.
Rick Silva, LADWP.
Mike Wayman, Eastern Municipal Water District.
Joe Berg, Municipal Water District of Orange County.
I think I heard Joe Berg with MODOC, and Elizabeth, did I hear you as well?
Yeah, EMWD, yep.
Okay.
Carrie Pollard, Sonoma County Water Agency, and Brian Lee with Sonoma County.
David Wallenstein from East Bay Mud, here with Charles Bolig and Scott Sommerfeld.
Okay. Anyone else?
Dr. Samasgan, DWR.
Amanda Doherty with SFPUC.
Oh, great. You guys got on. That's great. Okay. So I think that's everyone. Just a little bit of housekeeping while we're presenting. If everybody could, number one, make sure you don't put your phones on hold, and if possible, if you could put your phones on mute. And then we will have opportunities for Q&A at a couple of times during the webinar. If something comes up while we're speaking and you really want to ask a question immediately, I think your controls give you the option to type in a question. So we'll be looking at that too. Just kind of to give you a quick agenda, I'm going to give you a quick update on where the project started and where we're at now, and then I'm going to really hand it over to Carlos so that he can actually show you what we've accomplished throughout this project. So with that, I'll go ahead and get started. Let me get control here. Okay. So the ET Data Protocol project is a project that we're providing the update on. It was originally designed to provide enhanced statewide ET data for irrigation controllers and other applications. I think I have control. There we go. As I mentioned, it was a grant-funded statewide project in partnership from a major grant from the California Department of Water Resources. And water agencies, all of your agencies were co-funders to this, in addition to Metropolitan Water District, who I don't think I heard on the call. And it was also UC Davis. Some of the work that they were doing was involved. And we also had participation from controller manufacturers, the irrigation manufacturers, on what their needs were, and had quite a lot of meetings with them to get their input. So the total project budget for this was $261,000, and of that, DWR provided I want to say Prop 50, but now I can't remember. It might have been 13, but I think it was Prop 50 grant funding for $156,300. And then all of us collectively, us water agencies, we committed to co-funding and have provided $105,000 in funding. And I'm very happy to report that the project is on track and on budget, so that's great news. When we started this program, our project objectives were to be able to support and expand water-saving ET-based products, technologies, and applications through the development of what we called ET XML. And when Carlos presents, I'll let him explain a little bit more about that. We wanted to do it collaboratively with DWR and with the CIMIS program, and to be able to provide a reliable statewide quality control data source. As most of you know, there's been a lot of emphasis on outdoor water use and water savings, and ET data comes into play quite frequently related to water budgets and applications. And we wanted to be sure there was a really good, reliable source, and our other key goal was that it would be at no cost, because we wanted to be able to see these technologies widely deployed so that we could benefit from the water savings. The goal was to provide the ET data at a 2 square kilometer resolution in an easily accessible standard format. And as I mentioned earlier, we had stakeholder involvement in the process from water agencies. We provided input at the front end, and we've also, as I mentioned earlier, we met with the irrigation manufacturers. We actually had on-site visits with many of them and with their development folks to talk about what they really needed. So the ET XML web services, what really is that? It is a service that really allows CIMIS weather data to be shared over the internet. And we're all familiar with websites, and since I'm the non-techie on this webinar, the easy way for me to describe it is websites are for us humans to use, and web services are designed to be used by software and applications that basically would use that data. So basically anyone that wants to can create a software or application that basically requests CIMIS weather data from the ET XML services. And then that software hopefully is going to do something useful with it, like provide irrigators information regarding their water schedules. So the project, I was talking with Carlos, I can't believe we actually started this in 2008, and that was this project. Carlos and I actually even we worked on a pre-project to this, a proof of concept project, so it goes back even further. But this particular grant project started in 2008. We did modify the original scope. Originally we were going to deploy controllers that were using this data and have that as part of the scope of work. Instead, we decided that because of the SWOT testing that we didn't really need to test whether the controllers were working. There was already a protocol in place for that. And so the $26,000 that was originally going to be used for that purpose, we actually transferred it to augment the development of a Windows-based app, an online registration system, so that we could allow public access to the services. So that was actually a very positive enhancement and modification. As a lot of you know, because a lot of you also had other grants, did I just move the page? We received a stop work order from DWR in January of 2009, which was rescinded later that year. Because of that delay, the original completion date of April 2010 was extended out to the end of this month. And just to cover some of what we actually have accomplished, and Carlos is going to show you more of it, but we have 17 registered users using the ET data protocol to support water-saving technology and applications including smart timers and applications for water budgets. Some of those registered users include some of the large irrigation manufacturers, Toro and Rainbird, for example, and a lot of the other smaller manufacturers. CyberRain is one. There are others who are developing new applications and technologies. We also have organizations using the data. Eastern Municipal Water District, the University of California Cooperative Extension are a couple of them. And MODOC was actually, they're not currently using the data, but just to see where this is going to go to in the future, Municipal Water District of Orange County, Joe Berg, submitted a grant application and was awarded, and it will build upon this work to be able to deliver emailed sprinkler index information by subscription. And that will be something that water agencies will be able to offer out to their customers in the future. So if anyone's interested in that, contact Joe Berg at the Municipal Water District of Orange County. Some of the final steps that we have, just to wrap up, on the project, we did a stakeholder outreach webinar with the irrigation manufacturers, and Carlos actually did that. It was a very technical workshop, and we did that on November 8th, so we did that last month. Another task that we had was a final meeting with the stakeholders, with the co-funders. We're doing that right now. You're part of that. And then we have to prepare a draft final project report for the Department of Water Resources by the end of this month. So IRWD is already hard at work on that. As a side note on that, one of the things, if you're not in Met service area and you have any information on the number or manufacturer of any smart timers you may have distributed since 2009 and could just send that to me, I would really appreciate it, because it helps to demonstrate the technologies that are actually supported by and using these web services. So we would just need to know how many and the manufacturer. I already obtained for all of metropolitan service area that information. So if you're a Met agency, I already have it. And then, so we'll be sending the draft final report to DWR, allowing them comments. And if you all would like to be included in, we will actually, not if you would like, we will copy all of you on the draft final project report so that you can take a look. And then the final report to DWR will be due in March of 2013. I'm going to briefly ask right now if anybody has any questions about anything that I have presented. Otherwise, I am going to turn things back over to Carlos. So I'll open it up right now if anyone has any questions regarding the information on the project.
Hi, Fiona. This is Bakala. I just wanted to comment. No, it's not a question, but I have another meeting to go to right now. But I wanted to comment that in addition to funding, I think it is Prop 50 from DWR, CIMIS also recently contributed resources to this project, and they added some features that were not originally in this project. So some of the upgrades that we have in this application was partly funded by CIMIS program.
Absolutely, and actually I want to really recognize and thank DWR and the CIMIS project, because really we wouldn't have been able to accomplish what we did without your collaboration and cooperation and partnership. And as you mentioned, there have been resources allocated to support this and move this forward. And Carlos is going to talk a little bit about some of that too during his presentation. But definitely want to thank you very much for all the support for this project.
Thank you.
So does anyone else have any questions about where we are? Or okay, so with that, I am handing control back over to Carlos, and I will let him present the fun stuff.
Great. Thank you, Fiona. Again, this is Carlos Ortega, Enterprise Information Systems. I'm the Chief Architect and developer of the CIMIS website that some of you may be familiar with. I've also worked with the ETXML web services that Fiona's discussed, and most recently, the evolution of the ETXML web services into something we now know as the CIMIS web API. Fiona, did you, it looks like I do have control. Let me go ahead and switch over to the other presentation. All right, here we go. All right, so I did want to talk to you briefly here about the types of data that the CIMIS web API will provide. And in fact, let me go ahead and just talk a little bit about what we mean by CIMIS web API. As you know, the ETXML project has been around for quite some time, but there was a need that was identified to extend beyond the current product offering to include other services that would be useful, essentially exposing more CIMIS data to its customers. And that's where the whole concept of the CIMIS web API is. It's essentially the ETXML web services live within or are a subset of the services provided by the larger CIMIS web API. And a little later in this presentation, I'm going to show you essentially what's been added to the service offering. But for now, let's take a look at this slide. CIMIS data providers. What I mean by that is, what are the different data providers for the CIMIS program? There are essentially two. The first is a CIMIS weather station network, and the second is something called Spatial CIMIS. Okay, CIMIS weather station an is a collection of over 140 active weather stations randomly placed throughout the state of California. And here you kind of see an overview or a snapshot of the Bay Area and a portion of the valley here. And you can see the little markers on that map. If you're familiar with the station map in CIMIS, you've seen this before. Essentially, each of those markers identify a weather station that exists at the locale indicated. And each of those numbers represent the station number for those locations. And as you know, weather stations are able to capture a broad range of sensors. I call it being very data rich. We capture anything from air temperature, soil temperature, wind speed, solar radiation, and everything in between. So you'll see here that the coverage, meaning the areas that are covered by these weather stations, are substantial. I wouldn't say they're comprehensive because there are areas where stations don't exist, mountain ranges, far north, far south, and certain areas where a station may not be. So essentially, the weather station network gives you very data-rich information for the areas that they cover. And of course, when you request data for a weather station, you'd be doing it by either the station number or the zip code. So that's the weather station network data provider. The second of the two is the Spatial CIMIS data provider. Now, the Spatial CIMIS data provider interpolates data, ground sense data, data from those weather stations, along with satellite information, specifically GOES satellite information. And we're able to provide data, and when I say data, I'm referring to solar radiation and ETO data at the moment. We're able to provide this data statewide at a 2-kilometer resolution. And requests for this data may be made by coordinate, that's decimal degree coordinate, address, or zip code. So when you take a look at both of these providers, you have the weather station network, which in the documentation that I provide, I refer to it as WSN, and the Spatial CIMIS system, or SCS. You'll notice that the weather station network provides both daily and hourly data. So you have a very data-rich data set for daily and hourly data coming out of the weather station network. On the spatial side, at the moment, we provide daily data. Now, what are the differences here? First of all, they do share something in common. Both the weather station network and the spatial CIMIS system provide data by zip code, daily data, that is, by zip code. And the weather station network will uniquely provide daily data by station, and then, of course, the hourly data by station or zip code. The spatial CIMIS system provides uniquely the daily data by coordinate or street address. So let's take a look here. A very popular zip code, good old 90210. And in this zip code, you'll notice, actually on this map, you will notice that it's separated in a 1 kilometer grid. So this 1 kilometer grid is overlaying this zip code. Now, the reason I bring this up is because the spatial CIMIS system has the ability to provide to its users averaged code data. So the way it provides the averaged zip code data is it averages the information that is contained within this grid. Okay, but before we do that, let's take a look at a coordinate, how it will do a particular coordinate. Notice here the marker A. We're looking for the information for that coordinate. What happens in the within the CIMIS web API is we take a request that says we want, latitude X, longitude Y. Let's say it lands us here on the map, and notice that 2 kilometer pixel. We will provide ETO and solar radiation value for that 2 kilometer square. But what if they want an averaged zip code? What we do in this case is we essentially rasterize the entire state of California, the map of California, and we break it down not in 2 kilometer squares but in 500 meter squares. So it would look something like this. Now, the area that's the value for this 2 kilometer area that we looked at earlier, the value for that entire region will remain the same even when it's transposed over this 500 meter area. And essentially what we do is we average all of the squares where the centroid of the square falls within the polygon of the zip code. We average all those together, and we're able then now to provide averaged ETO and solar radiation data for the zip code. This is exciting. This is exciting stuff because providing that average was not is something I know that a lot of customers want, or a lot of people want within their product, is to be able to provide that zip code capability. Although it's better if you get by coordinate, if you're able to get geocode to an address or whatever within your application, better to get it by coordinate because it's more accurate. There are many microclimates within zip codes, especially the larger zip codes. But if you're able to get by coordinate, even better. All right. So what is the CIMIS Web API? The CIMIS Web API offers CIMIS data to the public free of charge via a web application programming interface. So this is really the first time we're providing an offering under what the industry calls a web API. This is a true web API. I'm not going to get into the nuts and bolts of the technology, but essentially it provides a tool set that will allow developers to access this data and integrate the data within their application seamlessly. And it won't matter whether, it doesn't matter what language they use. As long as they're able to access web services, they will have the ability to use these services. And you should know, of course, that the CIMIS Web API is not only an extension for, but also a replacement of what we know as the ETXML system. It basically will envelop ETXML along with the additional services I mentioned earlier. So what are the plans? DWR will continue to support the current ETXML system currently in production 1 year after the GA release, which is scheduled on December 17th. So December 17th of next year, CIMIS is not obligated to support the ETXML product in favor of the new CIMIS Web API. And of course, DWR is not obligated to continue to host the current system. They may choose to or not, but that's at their discretion. All right, so what's new? This is the exciting stuff, a lot of new things. You know, when we started this project so long ago as a proof of concept system, we had a pretty basic subset of features. We were doing only SOAP protocol, and I'll talk briefly about what REST and SOAP are, but I know that's not as important for this meeting. It was more important really for the technical meeting. But when we first started, we were doing only SOAP. We had a subset of features, and then we were able to parlay a lot of the resources into getting this into production. We recently had the enterprise architecture and all the hardware made available and quickly moved to getting us to the finish line here, which we anticipate on the 17th. Okay, support for REST and SOAP. So what's the big deal here? Well, SOAP, it's a very nice protocol. It's generally used by business. It has the capability of being very highly secure. It does come with some overhead. In order to use it, you need something called the SOAP stack. And some developers who may not be familiar with that may have more difficulty in implementing with SOAP because there's a little more of a learning curve using it than with REST. Now, REST, the REST protocol, is something that we've introduced as part of the CIMIS Web API offering. What the REST protocol allows us to do is to provide our services over the internet through something as simple as a web browser. So, you know, really, you're able to use this stuff right out of the box without even having a development environment. If you have Internet Explorer, if you have Firefox or any browser, you're able to obtain information from these web services, and I'm going to demonstrate that a little later. As a result, most of our users, in fact all of them, have switched to REST. They prefer REST over SOAP simply because it's easier to use. In our initial offering, we only provided data in XML format. You know, lots happened since the initial release of the CIMIS Web API. One of those things is the emergence of REST and the emergence of JSON as a protocol for representing structured data. So JSON is now supported as well as XML. So that's a huge leap for us. Also, the old system used HTTPS because, well, we were transferring username and password information over the internet, so you really did need that. The new system uses something called an application key, and it's very similar to what Google uses for their Map API. Now, because of that, there's no need for transport security, so we switched from HTTPS to HTTP. Bullet point 4, there's no authentication. I did mention that. Bullet 5, station and zip code services. Now, the new API provides more support for, well, the old API had station and zip code services, but the new API has the averaged zip codes, so a little more in that arena. Simplified interface. Okay, so the interface is much simpler now. When I say interface, meaning the way developers would write code to obtain information from the Web API, it's been greatly simplified. We won't get into that so much. We covered that during the technical presentation, but that's essentially one of the features of the new system. And then updated zip code support. This is big because really the initial offering for zip codes was based on the 2005 census data. The census data includes polygons for each zip code, essentially, and we use that information to provide the averages for each of the zip codes. Our good friends at UC Davis who are working with the spatial CIMIS portion, you know, they are going to be updating the system to include more and more zip codes, including the 2010 census zip codes. And at the request of DWR, Becala to be exact, we have an address feature now in the CIMIS Web API. In the past, people would have to use Google Maps, geocode an address, obtain the latitude and longitude, and then provide that information to the CIMIS Web API in order to get their coordinate data. Well, now you're able just to enter your address, and the Web API will geocode and get your information for that address. Now, the last bullet point, this is particularly important. Improve enterprise architecture for reliability, durability, and scalability. Now, this is something that will roll out with the larger CIMIS project, and that's coming sometime next year. I don't want to give dates here because that's not my role, and I don't know when those dates will be, but the idea is this. The new CIMIS product, meaning the CIMIS website, is going to be rolled out at some point next year. Now, what that will include is improved architecture, an enterprise architecture with redundancy and a more durable infrastructure. And the CIMIS Web API, being the forerunner of the CIMIS Phase 2, which will be released again sometime next year, will benefit from that architecture. Okay, SOAP and REST, we talked about that. We talked about JSON and XML. These are the services that are provided. Now, the data service here, that provides everything the ETXML service did in the past. That one service provides it all. Then, of course, you're able to get station information now. Very important. If you're writing applications against CIMIS data, so for instance, if any water agency out there wanted to obtain information by station, you'd want to know what stations are available, what stations are active, where the stations are located, what city the stations are in. And in that way, you'll be able to identify which stations are of interest. So this station service will provide that capability. And the latter two services indicate which zip codes either one of the data providers support. So we mentioned, the weather station network and spatial CIMIS system. Well, each of those data providers support some set of zip codes. The spatial CIMIS system, the spatial CIMIS system would provide, a larger set because it's pretty comprehensive. It's going to be using 2010 census data. So that'll be a pretty big data set there. The idea is you'd be able to know up front by using the service which zip codes are serviceable by CIMIS. We talked about no authentication. All right, I guess it's demo time. Now, there's a few ways to demo this. I kind of want to show you the CIMIS system very quickly here. Now, I'm using zip codes here that belong to IRWD service area. And the idea here is we want to be able to provide, zip code data, spatial CIMIS zip code data. Let's get it for the past few days here. And we can run a report, and again, you could do this on the CIMIS site. You could see here you get information, ETO information for those zip codes. Back it up. And you can also, if you choose the map capability, you're able to zoom in here and choose locations of interest to you from the map, or you could type in the address here. The reason I show this is it's a visual representation of what the CIMIS Web API provides for you. You're able to do any of this stuff directly through code without having to go through this interface. So you can develop your own interface. If any water agency would be able to create their own interface to provide their customers or themselves with the information that is behind CIMIS using that API. So that's what it would look like if you look at through a finished application. let's take a look at the actual CIMIS Web API website. So there's a website out here. So if you have developers or if you yourself are interested in accessing these web services directly, this is the URL you would go to. And again, I can provide these slides and any information that we've discussed today on this website. In fact, if you scroll down to the bottom of the home page, you'll notice I posted the video for the technical group right here. And this gives very detailed information in terms of how to access those web services. So if anyone's interested, just visit that URL and you'll have access to that. So here, under REST, because again, most of the REST protocol, you're able to get detailed information on how to access each of these services. And one of the really neat things is if you go to the online service tests, you're able to plug in an application key, and essentially it will create a set of what I call unit tests, which is examples of how to use the services. So you plug that in here. And essentially, hold on, let me see if I can find, if I have a slide. No, apparently not. Okay, so hold on, let me cancel that. I'm gonna click this link and download the actual product of that service call. Now, when you open it up, you're going to see a lot of text here. This is the actual data, okay? And again, it's not as human-friendly as something that's well-formatted is, but I'm going to display that same data using something called Pretty Print, so it's easier to view. So this is the data that comes back from a web service call. And as you can see here, you're looking at CIMIS station data, and you can see that station number 2, and it's in English units for this zip code. And you're looking at air temperature here with a value of 39 in Fahrenheit. And this is kind of how the data appears. And this is JSON format, by the way, JSON. So it's really that simple. I just closed it. Okay, so here we are. And of course, these are different examples of how you use the CIMIS Web API. In this case, we looked at daily data by station number. And again, if I click it, there it is. It comes up. Here's daily data by zip code. And this URL right here, you can plug right into your browser. You'll notice it says http://, and then here's the domain name, and then all the parameters required to obtain data. And in this case, you notice the application key here. That is the key that uniquely identifies the user who is making the request. And then the various targets here, notice there are zip codes, identify the zip codes that are of interest, and the start date and end data there, of course, self-explanatory. And then over here is a list where you see where it says data items. Let me see if I can zoom in here a bit. Maybe that'll make it easier. Here it says data items, and we're looking for air temperature max, minimum, and so forth. And this is essentially the way REST works. Pretty straightforward. Anyone can really do this. All you need to know is what the parameters are, and what's acceptable. You could type it right into your browser, and that will work. In fact, let me grab this right here. I believe I can just copy that. Open up another tab, paste it in, hit enter, and what will happen is we already have our data back here, see? And we can open that up. Again, I use Notepad. Open it. And it's again, a little bit cryptic when you look at it this way, but again, this is not for human consumption. It's the way one software application communicates with another. So really that's straightforward to get you to your data. All right, so with that, I'd like to open it up for questions. Is there any questions about anything you've seen here today?
This is Dave Wallenstein from East Bay Mud. I had a question. It says the URL says it's a test. Is that currently available, or we have to wait for the final version?
Let's see here. The URL said test.
It says rest/test, the one we were just looking at with all the code on it.
Oh, this is no, it's available. I'm trying to figure out where
at the top on the URL for this web page. If you go to the top.
I see what you are saying. Okay. No, what it's saying there is that these are test scripts. So it's generating these URLs to allow us to test to make sure the system is still up and running. But the system is live and it's ready to go. The word test here simply means it's a utility to allow developers or the Department of Water Resources to test these services to make sure they're continuing to run as they should.
Okay.
Does that answer your question?
Yeah. I just wanted to make sure.
Okay, great. Thank you. Anyone else?
Carlos, I have maybe a dumb question. This is Amanda Doherty from SFPUC. So when you're talking about zip code data, where would you get that for San Francisco, since we don't have a nearby CIMIS station?
Right, San Francisco, because stations are sparse in that area. The best really is to depend on the spatial CIMIS system. Because you will get zip code data for every zip code, well, statewide really, in San Francisco using the spatial CIMIS system. So, see here, let me show you.
Carlos, could you do a demo and just show how to do that?
Oh, sure, absolutely. So, one thing we can do, let's demo it using the CIMIS website, because really it uses the same technology. Let's see here. All right, so here we are. Can someone off the top of their head know zip codes in the Bay Area or in San Francisco?
You could do 94102.
02. Let's see if that is there. Okay, so submit. So here you go. And we could actually do one using the web API also, but here you see you're able to get information past, 7 days for that zip code. Let's use the CIMIS web API to do the same. All right. Okay, so daily data by zip code is what I want. Here we go. So I'm going to augment this request. And let's see, I want the zip code of, help me out again,
94102.
94102. Interesting. Oh, I should have done daily. Grab this here. And what we're interested in is really just ASCE ETO or and solar radiation. So let's pull those guys. There's day ASCE ETO. Let's just do that. That's fine. I see this. Okay, so there's a request here where we want information from January 1st to January 1st, so 1 day of data here. Let's make it, that's fine. So I copy that, and I can paste it into the browser, and we get data. And let's take a look at our data. So here we have it. I'm going to put it into Pretty Print, so it's easier to read. Where is that? There you are. Okay, so here's our data for that one day, for that zip code in San Francisco. Right, so that's averaged zip code data for that zip code, yeah. So really that's how you'd go about doing it, really as simple as that.
Thank you.
No problem.
Carlos, what if you want to can you do a demo showing us how to pick like maybe 2 or 3 zip codes and get an average?
Oh, absolutely. Let's do that. I'll take the request that we had initially here. You guys just want to call out a few zip codes, and I'll add them here.
For San Francisco?
Anywhere.
Oh.
No, San Francisco's good.
For San Francisco, okay.
94115. Let's do 94118.
94118. Let's get a few more days, shall we? So maybe 7 days. And we're looking at it in English units now. We can change it to metric if we wanted to, for instance. But let's go with that for now. And let's plug it in here. We have our data back. There's our data. And let's see here. Where was my pretty print? All right, here we go. So we have spatial data. The zip code's 94102. And we have several days of that, 94102, and these are the different days, the first, the second, the third. And then it's repeating now for the first and second and third, but this time for 94115. Again, it's repeating for the first, second, and third, but this time for 94118. And there you have it.
So is it giving the ET for each individual zip code that got selected? It's not an average for the zip code.
Right, it's giving the average.
Returning, yeah.
Right,
it looks like it's
the
returning the ET for each zip code that you selected, right?
That's correct. The zip code for each zip code, and this is the averaged. This is the averaged zip code. Now, one thing that you should note, like in the future, let's say a new zip code emerges somewhere, right? Well, that wasn't part of the 2010 census, so that won't have an averaged value. You know, CIMIS will still be able to provide a value for that. You just simply need to find the coordinate or the centroid for that zip code, and you pass it in not as a zip code request, but rather as a coordinate-based request. And CIMIS will provide you the data for that zip code using that centroid. And yeah, so really, this will adapt. And CIMIS is, I'm sure, going to generate a strategy for how to maintain updated zip codes going forward. But yeah, that's essentially how it works.
Couple quick questions. Right now, I guess our feed is limited to 25 zip codes, and we actually have 64. Is there plans towards raising the number of zip codes that we can get? That's the first question. The second question is how much historical data is stored in this version?
Right. Okay. Let me tackle the last one first. How much historical data? Beckler, are you still online?
I think you had to get off the call.
Oh, okay. Yeah.
Hey, Carlos?
Yes.
I came back. My meeting is at 10:30, so I have about a couple of minutes. This spatial CIMIS data goes back to 2003. I think it is February 2003. So for going back all the way to 2003, you can get data for every zip code that is in our database. And what was the other question? I kind of forgot.
So, yeah, the other question was, right now we support up to 25 zip codes at a time.
This is on the website, is that correct?
I believe so. Is that what you're referring to, the website or the web API?
Yeah, the website.
Okay.
My name is Charles from East Bay Mud. We're getting the emails for our IRIS program every day, and they come in groups of 25. And we can't get larger than that. We got 68 zip codes, and we're wondering if it's going to be increased so we can just get one delivery per day.
Okay, that one would still remain to be the case, but I think the CIMIS web API that we're discussing right here, I would say this can handle more than 25 zip codes. Don't you say, Carlos?
That's correct. The web API should allow virtually unlimited zip codes. Here's the issue though. The web API has a data limitation built in because, I mean, if someone wanted all the historic data for all the stations, it would bring the servers to their knees. So there has to be a limit, clearly has to be a limit there. So I think you'd be safe with requesting all those zip codes. It would depend on how much data you wanted for all of them. What will happen is, let me show you, hold on, let me show you this page here. The REST page describes that. There's actually an exception here. By the way, this section here that I'm showing you now are exception tests. There are ways of testing situations where, there's some error in the request, like an invalid application key, or providing a station that's not there, unsupported zip codes, coordinates not in California, etc. And one of them should be data volume violation. So this is if your request exceeds the total amount of records that are a limitation to that service. That's the only kind of caution there. And each type of report, each style of report, like daily report, hourly report, they all have different thresholds. So in this case, the current data volume limitation is this, that 5,020 records is the max that you can do per request using the web API. And again, this is something that, we want feedback on as part of the whole, beta program is to get feedback from users. Some of the feedback might be, hey, your data limitation's too low. Can you double it, or things like that. So that's the kind of feedback we're looking for, and then we can make adjustments.
Is it 1750 or 5020? Because the language says the daily report request exceeds maximum data of 1750.
Hold on here. The daily report request exceeds the maximum data. Oh, okay. Yeah, you're right. I'm sorry. The limit is 1750. It just so happened that in this request below, 5 stations times 1,004 days would have been 5,020 records. So my mistake. The limit is 1750, and the problem is the request is asking for 5,020.
And Carlos, on this API, does this get sent out once you set it up? Does it get sent out nightly, automatically to your system, or do you always have to request it?
Actually, it's done by request, so it's up to the client, meaning whoever wants to consume these services. It's up to them to decide when they're going to make the call. So this isn't where you'll get an email or something like that. You would actually invoke it on your end and obtain a response right away. Does that make sense? Or let me elaborate on that a little bit.
So
okay,
Carlos,
so
what you're saying is it's a pull, not a push.
Correct.
But someone could set up on their end a little script that would automate their requests, right?
That's right, and that's what a lot of clients are doing. Just that is they'll write a little program, and in it will be some scheduling device that wakes up, let's say, every few hours, and every few hours it will go and make a call and fetch data. So that scheduling mechanism of when things happen occurs not on the web service side, but rather the consumer of the web service would deal with that. All right, so anything else from anyone? All righty. Fiona, I'd like to bat it right back over to you. I don't know if you wanted any closing words here?
Not a whole lot. I'll just reiterate my request that if any agencies not in Met service area have a summary of numbers of controllers you might have rebated on or otherwise since 2009, I'd really appreciate getting that if you know the manufacturer, because we can match that up to which manufacturers are taking the data. For example, as I mentioned earlier, Toro and other manufacturers, and that would be very helpful information for us to incorporate into the final report to DWR. So I will probably, this afternoon, I'll send you all a request maybe for that information, but if you do have it, it would be very, very helpful if we could get it by the end of this week. And I really want to thank, again, DWR, Carlos, and actually all of you for helping to co-fund this project. Hopefully the ET data that we'll have, and as we get in the first, hopefully half of next year, all expanded CIMIS, the spatial CIMIS and everything fully operational, we'll have better quality data. We're going to have ET data that provides much greater coverage to support a lot of our water conservation efforts. And I think for me, seeing sort of some of the technical applications, I know there are programmers that are using those. IRWD intends to write some programs to get better coverage for us for setting water budgets, and we can do that internally, or I guess Carlos could always help us out in writing a small application to do that on our end if we wanted to work with him. But so there's a lot of ways that we can use it, and I think too to realize that some of the largest controller manufacturers and smart timers that a lot of us are putting out there, they're actually using this data now that we have helped to co-fund. And so I know when we first started doing ET controller programs, we were concerned that the ET data the controllers were using wasn't very representative of certain parts of our service area or other agency service area. And so a lot of that has been substantially improved from this project. So I really wanted to thank all of you for participating in this program and helping to co-fund it. I think it's something that we're making a big difference for in the state, and that it's going to go on to other applications. I mentioned earlier the program that Joe's going to do. Joe, I'm not sure if you're still on the phone. Do you want to mention that, or?
Yeah, thank you, Fiona. I was hoping that you'd throw that opportunity out, otherwise I was going to make a shameless plug myself. Basically, if you guys, I'm not sure if outside of the Met service area if you're aware, but on Met's bewaterwise.com website, they have an irrigation index. There's actually two tools on that website. One tool allows someone to develop a base irrigation schedule. Actually, it's a month-by-month irrigation schedule based on the characteristics of each irrigation valve they have at their property. And so if you take the peak month and use that as your base schedule, you can then apply the percent adjust feature on many of the irrigation timers, the standard timers. And Met has published that index, and you can get it on a weekly or a monthly basis, but you have to go to the Met website to access the updated index number. And I believe that while some people may go to the website to get it initially, I think that over time they will discontinue accessing it. And so what I'm working on with a grant from the Bureau of Reclamation, funding support from LADWP and IRWD, MODOC, and I'm trying to seal the deal with MET, is to create a push method of getting that information out, whereby that index number would be emailed to someone who registers to receive it, and they would choose between a weekly number or a monthly number. And the water agencies that are administering this particular tool would have the ability to put customized messaging in the email to help promote water awareness and incentive programs. We've had 2 meetings on it so far, and just recently we saw some screenshots of some of the pages that are being developed, and it'll be available to agencies throughout the state at no cost in terms of accessing it, but there may be some minor costs to host it. You'll be able to host it on either one of your own servers at your agency, or you could host it on the cloud. Initially, for Orange County, MODOC will be administering it on the cloud, and as agencies in Orange County want to assume administration of it, they can, and that'll give them the ability to do customized messaging for their agency. You can put seasonally appropriate irrigation maintenance messaging in there. You can promote drought response activities depending upon the water supply situation. So we're excited about it. And if you'd like to learn more about it, feel free to give me a call, and I'll be happy to give you an update on it. Eventually, when it's completed, I'm assured that I'll be able to make a presentation on it through the CUWCC.
Okay, thanks, Joe. So that's just another example of the foundation that we've all helped to create together with DWR, and how that's going to help us support our outdoor water use efficiency efforts. So I'll just wrap up. Amy and I are working on the draft report, which we have to send to DWR by the end of the month, because neither of us are here after the 20th. Our goal is to get it out on the 20th. So if you have anything you really want us to incorporate up front, you can send us that feedback beforehand. But what we will be doing is we'll copy you on the draft report, and then we'll have an opportunity to incorporate any comments that you may have on the back end. On the screen, and I believe you all have emails, I'll be sending out another one today, and I usually CC Carlos, so you should all have both of our contact information. If you have any further feedback for Carlos, either on the product or questions on how you can use it or adapt it for what your agency needs, he's a great resource. And if you have any questions more about the project or anything on the final report, let me know. With that, I don't know if anyone has any final comments. Otherwise, I just want to thank you all again for your participation, and thanks for participating in this webinar.
All right, thank you.
Thank you, everyone.